Hello everyone, so how are you? So today I'm solving this problem, number of good leaf nodes pairs. Okay, so basically we are given one binary tree like this, and we have to find the number of leaf nodes which are at a distance given in this question, like distance variable is given to us. So we have to find all the pairs, number of pairs of the leaf nodes which are at a distance of either equal to this distance or less than equal to. Okay, so we have to find such. So for example, take this example here. See, distance is given 3. Okay, so if you look, 3 and 4 are the leaf node, and if you look at the distance, there are 1 2 3 distance, so there is only one pair. Okay, so we have to return 1. Similarly, we can see here in this example, 4 and 5 are the leaf nodes, right? And the distance is given as 3. So we have to find all the leaf nodes which has all the pairs which has less than or equal to 3. So here 4 and 5 at a distance of 2, right? So one pair is this. Another pair is 6 and 7, that is also at a distance of 2. But if we take other pair like 4 and 6, they are at a distance of 4. 5 and 6 also at a distance of 4. So it is greater than 3, so they cannot include. So there are only two pairs, 4 5 and 6 7. So this is all what we have to do. But let us see how do we approach this problem. So let me draw a diagram. So guys, our approach is simple. What we will do is, at every node, okay, every node we will write a function which will basically return us the left side list of the distances of leaf node as well as the right side distances of the leaf nodes. Okay, so we will write this kind of method, and from those distances we will try to find whether we are getting a right pair or not. So this would be a bottom up approach. Okay, so let's dry run a high level dry run here, that how it would work. So for example, we are calling our function first of all at root, right? Then it will go to directly for the left child and right child. Okay, then it will keep on going left child and right child. Okay, then finally it would be reached to some leaf node. Okay, so any leaf node, okay, so it doesn't have any left child or right child, correct? So this guy has to send a distance 1, right? So whatever parent it has, like 4 has parent 2, right? So for 2 the distance would be go as 1 because this is the leaf node and it is at a distance 1, right? So in this case what we should return? In this case we should return a distance having the distance of this leaf node. So what is the distance here from 2? It is 1 only. So we will return from here 1. Okay. Similarly, see here at 5, this is also leaf node. So when it will come back to its parent, it is also giving a list of one distance, right? Because 5 is at a 1 distance. So see here. So from left side, this list has one guy, and similarly from right side, this has one guy, which has this is distance in this list. Okay, so finally what will happen? We will check both of them. Okay, so see here, if we sum up these distance, right? So the distance from 2 for 4 and distance from 2 for 5. Okay, so this would be list 1 plus 1, right? In this case we have only one element, so 1 plus 1, right? So what is the total distance? It is 2. So now this 2 is basically the distance between 4 and 5, which is a leaf node. Okay, and in this case our distance variable has the value equal to 3. Okay, so let's say we have this distance equal to 3. So see here, this is 2 and 2 is basically less than or equal to 3. That means we have found one pair. So we can have a count variable, and in this count variable we can say that right now we have value 1. Okay, now see here, after getting these two values, we can say that now after having this pair of this, then we have to return the value of this array at here, right? Because we are returning an integer array, an integer list basically. So at 2 what it would be returning? So see here, when 2 would be returning the value, a list to this guy, its parent, what it would have? It would be added this value, right? So from 2 these guys are at distance 1 and 1. So we will add 1, right? Because from 1 it would be one more distance, this distance plus 1. Okay, so whatever distance till 2 plus 1, that would be the distance of these guys 4 and 5, right? So it would be returning us 2 and 2, correct? So this guy would be from left side 2 and 2, this list would be returned, correct, because now 4 and 5 is at a distance 2 from 1. And similarly here also when we are coming from left side, then the method would be come to this left and this left. So see here at 6 it would be returning 1, just like that. Yeah, and similarly it would be returning the list of 1, because these guys would be at a distance 1 from this parent 3, right? So here it would be taking 1 and 1, and again we will check that 1 plus 1, okay, whatever distance combination. So 1 plus 1 is equal to 2. So this is also a valid point, right? Because it is less than 3. So we would increase count equal to 2, right? Now at 3 what we would be returning? We would be returning 1 plus 1. So 2, 2. So at this guy, what we would be returning? We would be returning 2 and 2. It is simple, right? You can see here that from 3 it was at a distance 1. So from 1 it would be plus 1, right? So plus 1 and plus 1. So distance of 6 is 2, distance of 7 is 2. 6 and 7 both are leaf node. So here 2 and 2, right? Now you can check from right side also 2 and 2, and as well as from left side also 2 and 2. Now we will go to all combination. Okay, so if we go like for all values of 2 and 2, okay, and another set of 2 and 2. So see here from left side or right side, from both sides if we add any two values, okay, all of them are at least becoming 4 only, nothing less than 4, but our distance is basically 3. So anything which is less than or equal to 3, then only we will increase the count. So here no combination would be making us 3 or less than, so no more point would be added here. So our final answer would be 2 only. Okay, so this would be our approach. So this is as simple as like very straightforward solution, but yeah, it is taking the time complexity would be n square. Why? Because see here when we are checking this, we have to use for loop, because we are checking all the combination, right? For loop for first list and then for loop for second list, so that we will get all the combination sum. So for that reason this would be O of n square solution. Now I will show you what is my solution and I will explain every point of it. So see here, I have created one count global variable, and this is util function. Okay, this util function basically I am returning the list of integers. So see here, if root itself null, then we are returning a null array list, right? Otherwise, if this is a leaf node, okay, then what we are doing, we are creating one array list and just adding one value, because for its parent it would be at a distance of 1, right? Okay, so that is why I am adding this and returning this sublist in case we are reached to any leaf node. Okay, otherwise what we are doing here, we are calling this function on the left child as well as the right child. So we got this left array list and right array list, and this is our this list that one will be parking all those values. So what I'm doing here, see here, I'm traversing through the left list every integer of left, then every corresponding integer of right. So for loop inside for loop. Then I'm checking if d1 plus d2, okay, whatever d1 d2, if it is less than or equal to dist, if it is, then we are increasing the count plus plus. Okay, so finally every point we are increasing this count in the global variable, which will count the pair of those leaf nodes which are at a distance less than or equal to dist. Okay, and finally what we are doing after doing this count stuff, then we are adding one value to every element of this left and right into this list, this one, the one which we created. So why we are adding? Because for the parent, for the next parent, the distance would be increased by one more, right? So for example, see, we are returning at 2. Take this example here. If at 2 we will get 1 here, but when we will return from 2 to this guy first node, it would be having the value 2 because 4 would be at a distance of 2. So for same reason I'm adding every value with 1. Similarly for the right as well, I'm adding every value with 1 into this list. And finally what we are doing, we are returning this list. Okay, so this is our util function which is returning us the list of integers, and in this count variable we have already done the count plus plus if there is any possibility. Okay, then what we are doing finally, we are using this function, we are calling this function in the main function, root and distance. Okay, so we would have done the count and I am directly returning this count. So let me execute this code. Yeah, so it is working fine, and I have already submitted this question. So let me submit as well. Yeah, so it is submitted. But can you guys see it is only faster than 40% of Java Online submission. So I have a follow-up question here for you guys, because follow-up questions are always expected in top companies, Google and Microsoft, right? So here now you guys have to do how can make it further faster with same time complexity, but it can further become the faster. So can we do something instead of using array list? Can we do some more technique which can make us a bit more faster? So that is your follow-up question. Please try that as well. So thank you for watching the video. If you guys have any concern, please definitely make a comment over there. Thank you.